Hello, welcome to our lesson on how to conquer completing the square, part A. This is going to be a multi-part video series, and today we will start and learn about completing the square, and you'll have to tune back in to learn more. Let's review some vocabulary. First off, completing the square. That's a method used to solve a quadratic equation by changing the form of the equation so the left side is the perfect square trinomial. A trinomial is an algebraic expression with three terms. And a perfect square trinomial is a trinomial that can be factored into a binomial multiplied by itself. So A plus B is a binomial. So this binomial multiplied by itself results a perfect square binomial. So it can be written as A plus B squared. When you multiply, you get A squared plus 2AB plus B squared. So we're going to use this idea to complete the square. A quadratic equation, just to review, is an equation that can be written in the form y equals ax squared plus bx plus c, where a cannot have a value of 0. If a were 0, then this term would be eliminated, and you would be left with a linear equation because you would not have an x squared term. All right, so perfect square trinomials. Let's review what they are and how to force one to have one. So we have our standard form of our quadratic. To create a perfect square trinomial, which is part of completing the square, you need to understand the relationship between the values of b and c given a perfect square trinomial. So let's consider this quadratic function, y equals x squared plus 16x plus c. So we don't know this value of c. So when you're learning the method completing the square, you're going to force one side of your equation to look like this, and you need to come up with a value that's going to create a perfect square trinomial. So when we look at this, we want to know what value of c that I could rewrite this to be x plus a value multiplied by the same binomial that's going to result this. So the relationship here, for this one, c would be 64. So if we look at this as a perfect square, 8 times 8 is 64. So if I rewrite this in standard form, it can also be written as x plus 8 squared. So when we go and we FOIL or multiply our two binomials, to get this, we're going to get x times x, which is x squared, 8 times 8, which is 64, and then remember the center terms are 2ab in this pattern. So 2 times 8 is 16x. So this would result, this is a perfect square trinomial because x plus 8 multiplied by x plus 8 is equivalent to this. So we're going to use this idea to create these perfect square trinomials. So note that the relationship here is that this value of b, 16, half of it squared is equivalent to c. 16 divided by 2 is 8. 8 squared is 64. So I'm going to ask you to pause this video and find the value of c for each of these. Come back and hit play when you want to check your answers. Welcome back. So half of -6 is -3. -3 squared is 9. Noting that we can write this as x minus 3 multiplied by x minus 3. This is our perfect square trinomial. Number 2, half of 2 is 1. 1 squared is 1. So here's our perfect square trinomial written in standard form, and our perfect square trinomial written as a binomial times a binomial. -10 divided by 2 is -5. -5 squared is 25. And again, in standard form and written as a binomial. So let's use this idea to learn to complete the square. So here's my quadratic function. Step 1, If necessary, we're going to set the equation equal to 0. So that's back to using the zero product property to solve for the roots. That's what we're solving for when we complete the square, our x-intercepts. So the first thing we need to do is set this up so that we can find our perfect square trinomial. So we're going to write x squared plus 10x, and we're going to add 4 to each side of the equation. So when I add 4 to this side of the equation, I'm left with just x squared plus 10x, and I have positive 4 on the other side. So legal move. Step 2, we're going to force the left side of this equation to be a perfect square trinomial. So we need to find what value for c can fit right here so that this is a perfect square trinomial. So half of 10 is 5. 5 squared is 25. So I'm going to add 25 to both sides because remember, laws of algebra, whatever you do to one side of an equation, you must do to the other side. So I have not changed the value of this original equation. So let's review. I've taken this original equation, I've set it equal to 0. That's the zero product property. Remember, when you replace y with 0 and you're solving for x, you're looking for your x-intercepts. That's what the solution of a quadratic equation is. So I've added 4 to both sides, and then now I've added 25 to both sides. So I've been fair and appropriate to both sides. So this next step, step 3, we're going to write the left side of this equation as a perfect square, and we're going to combine the like terms, the constants on the right side. So that would look like this. X plus 5 squared equals 29. So now we're going to do what we know to solve. We're going to do the inverse of this. We're going to find the square root of both sides, and as long as I do it to both sides, it's legal. So the square root of both sides of this equation. So the square root of a perfect square trinomial is itself, x plus 5. When we do this, general rule of thumb, you use your calculator, find the square root of 29, and you round to the nearest hundredth. Remember, square roots have 2. They have a positive and a negative square root. So I have positive and negative 5.39. Final step, I'm going to solve. So I'm going to subtract 5 from both sides, resulting in the 2 roots to this equation, the 2 solutions being negative 10.39 and positive 0.39. Remember, there are situations where you may have one or no solution. If your quadratic function is symmetrical about the y-axis, you will have, and it has a vertex on the x-axis, you will have one solution. The vertex will lie on the x-axis. Remember also that you can have no solutions, and that would result a square root of a negative value here, okay? With more practice and time, that will come. But remember, you can have 2 roots to a quadratic function, 1 root, or none, because the quadratic function is either vertically translated up and it doesn't cross the x-axis, or it's a reflection and translated down and does not cross the x-axis. So your turn. Go ahead and pause the video. Complete the square to solve for the roots of this function. Come back and hit play when you're ready to check your work. Welcome back. So the first thing I did was add 7 to both sides. Now I find half of negative 3 and square it, and I get 2.25. So I'm going to add 2 1/4 to both sides of this function. I'm going to write this as a perfect square trinomial. Let's note a little oddity here, a coincidence. Our negative 3, half of negative 3, is what goes in our perfect square trinomial, in our binomial expression. And I've combined like terms. Take the square root of both sides. So we have x subtract 1 1/2 equals positive and negative 3 4/100. Add 1 1/2 to both sides, and you get 2 roots. Negative 1.54 and positive 4.54. Okay, try another one. Sometimes functions are... Okay, welcome back. So first I found half of 2 and squared it. Half of 2 is 1, 1 squared is 1. Add 1 to both sides. Write it as a perfect square trinomial. Combine like terms. Find the square root of each side. x plus 1 is the square root of x plus 1 squared, and 16 has two roots, positive and negative 4. Subtract 1 from each side. So 4 minus 1 is 3, and negative 4 subtract 1 is negative 5. And there you have your two solutions, your two roots. Thank you for joining me today. I hope you'll come back and visit with part 2. Go ahead and subscribe to my channel if you'd like to see more, and give me a like. Thanks for joining me today.